Lesson 13.2 deals with polar equations of conics and other curves. Many equations are simpler to graph using a polar coordinate system. In a polar system, each ordered pair is represented with a radius of a circle and an angle of rotation. So your ordered pair xy actually becomes an ordered pair r theta. Now, in the ordered pair xy, x always represented how far you go right, and y always represented how far you go up. In an r theta ordered pair, r represents how many circle radii you're going to come out, and theta represents what angle you're going to rotate to. So the way your rectangular coordinates xy and your r theta coordinates are represented, or your polar coordinates are theta are represented, is x ends up being how far we come out, y ends up being how far we go up, theta ends up being an angle that is being rotated, r is the length of that value being rotated, and so you can see we end up with essentially a right triangle here, x, y, r, and theta. Now our definitions of polar coordinates says this: the pole in the polar coordinate system is the same as the origin in the Cartesian system. The polar axis is shown in the same position as positive x-axis in the Cartesian coordinate system. A point in polar coordinates is written as the ordered pair r theta, where theta is the measure of an angle in standard position whose terminal side contains a point, and r stands for radius, is a directed distance from the pole to the point to the direction of the terminal ray of theta. If I want to graph the ordered pair for 60 degrees, we would come out 1, 2, 3, 4 circles, and then we would rotate 60 degrees, and we would end up with this point right here. But since multiple angles are coterminal with 60 degrees, a polar coordinate can actually be represented in more than one way. And usually we write it 4 ways: a positive r, a positive theta, or a positive r and a negative theta, a negative r with a positive theta, or a negative r with a negative theta. And if it's positive, positive, we already have that as 460 degrees. But I could have also come out these same 1, 2, 3, 4 circles, but instead rotated this way, in which case it's all the way around less the 60 we went, or basically went 300 degrees this other direction. All right, another way we could have done this was, instead of going right 4 and rotated, we could have gone left 4 and started our rotation from this position, and then rotated in the positive direction, which is, notice, counterclockwise. So you're going to go 180 to get to here, and then that 60 that we had to get to there, 180 and 60, is 240 degrees. So that's a negative r with a positive theta. Or starting in this same position here, rotate, go negative r, but then rotate back this way. And that's going to basically be 180 minus the 60 that we had here, or negative 4 to send us left, negative 120 to send us clockwise. So this point can be represented 4 different ways rather than the single way that our rectangular coordinates are represented. And if we really think about it, we could add 360 or subtract 360 to all of these, and 420 is basically going to be that same point, because you're going to come out 4 units 1, 2, 3, 4, you're going to wrap around 360 and then that additional 60 and it's going to land there. So there are actually an infinite amount of ways we can list this same ordered pair in polar form.